All right, Craig, here we are in your real-time special relativistic world. Tell us about where we're at.
Well, this is an interactive game-like simulation, unlike the videos that we had before. Anthony Searle also was involved in creating this, but another undergraduate student, Lachlan McElman, also contributed enormously to the development of this software. So what we've got here is a little bit more complex world than the one we saw before, where we just had a building and a sign. There's all sorts of things here, but what you can see at the moment is some trees and a road, and I'm going to do exactly the same thing. I'm going to accelerate with constant proper acceleration down that road, and we'll see what we see. So here we go. If you look very carefully, you should be able to see the speed in orange at the top left of the screen. So we're accelerating towards those trees.
Everything's moving away, and that's because those arrows are coming around, and despite that moving forward, things look like we're moving back. But now we're going off, and we're actually coming up to the walls and things as we go through. So eventually...
So I just went through something there.
So eventually, when we accelerate, although initially things look further away, eventually we catch up with things, and they start appearing closer again. Mm-hmm. Okay, good. So one of the interesting things that we can do with this is we can look at... let's look at the trees. If we go through and accelerate here again.
Yep. And I can do things like turn the Doppler effect on and off as well. So that's with the Doppler effect on.
Oh, so that's not very interesting because everything just looks dark.
That's right, yeah. And part of what happens is that we shift the infrared and ultraviolet into the picture as well.
So the trees look bent over. Again, that's the aberration, not just in the one dimension, but in the two dimensions.
That's correct.
All right.
It's a bit hard to steer relativistically.
Yeah, I can imagine that it would be very easy to hit a tree when everything's distorted.
That's right.
Now, Craig, my understanding is that you have also some other worlds.
That's right.
For example, one that has, for example, a bunch of cubes where we can get a sense of what things look like.
Fascinating, yes. So I call it the cube lattice. And what I'll do is give you a perspective on that just by pausing but giving us a high velocity. So this is a freeze frame at high velocity. And because I'm traveling at high velocity, the image has, or the world has collapsed up in front of me, so I can see a lot of it now, which
so
I
we
couldn't
can really
see before.
see, because this is really, if we were going no speed at all, we would have just this big set of cubes that was perfectly square.
Yeah.
And we really see what the aberration looks like. We take this big field of view and we collapse it down, and we end up with this bulging thing in the middle, and sort of almost a pincushion.
So this is a lattice of hollow cubes. These cubes are hollow through all three axes. And what we're going to do when I unpause it is fly through the center one. So that's a wall of these hollow cubes, and behind it are actually two other walls. So we'll fly through this one and then through two more. Okay. So let me start that up and see what happens.
So we're coming very quickly. Now, this is kind of akin to what Luke Skywalker did in the first Star Wars movie, but it didn't look like this in the movie.
He was it's really hard to get through a hole. Whoops.
And trying to turn and get something into a little hole.
Very hard.
Looks really, really challenging.
It is.
Because everything is so distorted.
And distortions change as you change your direction of relative motion.
Right. All right. So, Craig, my understanding is that people can download this.
That's correct.
People are taking the class. And
yes.
so we'll provide the link so they can have their own little play.
Sure.
And you can try to experience the relativistic world in real time yourself. So let's finish off with a trip across the solar system.
Let's do that.
All right, Craig, let's take a trip to Saturn from the Earth.
Okay. So in the initial part of this movie, we'll see the Doppler effect as we move away from Earth. So you can see that the blue oceans went green and the land masses went red, and also the background stars reddened somewhat due to the Doppler effect.
So that's the Milky Way there. That's all been turned into kind of a dull color. I'm colorblind, but it looks kind of boring now.
Okay.
And here we're going to go by one of our sister ships. This is
a little solar sailor. It's deploying its solar sail right now.
All right. So this is the way that presumably we're in something like this ourselves, that we can speed up very quickly.
Well, it's interesting how fast you might be able to go on a solar sailor. Probably not quite as fast as we're going in this simulation, but maybe a few hundredths the speed of light is a possibility.
Oh, so we're speeding up towards it, which means it looks further away. That's always gets me.
Yeah, it's
But
very
eventually,
disconcerting.
the distance will catch up, and as we go through, we get incredibly weird distortions, and we're going to go, it looks like, right into the sun.
That's right.
Uh,
Well, of
okay.
course, the sun is out there in the sky, but it collapsed round into the front of us,
So
wherever it
now
was.
we've had the entire sky wrapped around, and we're coming up on Saturn, which looks very distorted.
Very strange.
So, traveling at 99% of the speed of light is going to help us get there quickly, because that means that you have all that length contraction from our perspective
Yes,
of the distance,
yes,
which means the time's contracted.
that's correct.
So normally from the sun to Saturn, 83 minutes at the speed of light.
Mhm.
But if we're traveling 99% of the speed of light, then that time is going to be reduced substantially from our point of view.
That's right.
Although from the sun, it looks like it still took us 83 and some extra bit of time.
It's
to
very
get there.
strange, yes.
All right. So traveling at the speed light, a very high speed, is going to be useful to get there. But once you get there, you're going to have to think about what you look at, because Saturn's ring doesn't look flat anymore. It looks warped.
Yeah, the reason that we stopped at Saturn and are all doing some orbits around it at the moment is because spherical objects, strangely enough, stay looking spherical, so they're not very interesting.
I'm getting kind of
Whereas,
seasick.
yeah,
here.
yeah.
I think I want to go slower when I visit Saturn myself.
Yes, you probably wouldn't want to orbit it at that speed.
All right. Well, that should give people pause to think about their trip to Saturn sometime in the distant future.
Well, we're going to finish off with the finale of flying through the rings. We accelerate up, and of course that makes Saturn move away, as we're familiar with now, but we're going
so
to
we're coming
come
at
through the
99% of the
rings
speed of light,
very fast.
and we're catching up. And as we go through, it does not look like a ring system at all, but still very interesting. And we can see the Milky Way, the entirety, which fills the whole sky, wrapped in to that tiny little part of the sky due to the aberration. Okay, well, thank you very much, Craig. That was a wonderful tour of the relativistic world and our solar system at nearly the speed of light. Thank you
Thank you.
very much.